Hi, my name is Nur Aida Akida binti Khairul Fuad.
Hi, my name is Maifurana binti Salim.
My name is Nadia Zairah binti Nizam.
Firstly, we will be using compound interest formula S equals to P open bracket 1 plus I close bracket in the power of N, where I equals to K per M, S is future value, P principal, I interest rate per period, and number of interest period, K nominal interest rate, M frequency of conversions, T term of period.
For scheme A, the P is 27,100, M is 4, K is 0.06, I is 0.015, N is 40. After transfer all the information into the formula, you will get 27,100 in bracket 1 plus 0.01, the power of 40. The answer is Rm 49,885 and 51 cents. For scheme B, the P is 22,500, N is 2, I is K over 2, N is 20. To get the future value for scheme B, you have to minus 95,049,885.51 cents. You will get Rm 45,114 and 49 cents. After transfer all the information to the formula again, you will have 75,114 and 49 cents equals to 22,500 in bracket 1k over 2, the power of 20. You have to divide the 45,114 and 49 cents with 22,050 cents equals to 1 plus k over 2, power of 20. You will get 2.005 equals to in bracket 1 plus k over 2, the power of 20. To get the k, we have to remove the power of 20 with root 20. So it will be the root of 20, 2.005 equals to 1 plus k over 2. You will get 1.035394179 equals to 1 plus k over 2. You have to minus the 1 with 1.035394179 and equals to k over 2. You will have to multiples the 0.035394179 with 2. So you will get 0.07078835707 equals to k. To get the answer in percentage, you have to multiples with 100. So your answer will be 7.08%.
After the investment period, compare the final balances in both accounts and the interest received. Recommend Khadija on which account she should choose that will provide a high return. Explain your calculation and reasoning as well as any assumptions you. According to the information given, K is 0.055, M equals to 12, T is 6 years, and P is 38,000. I equals to 0.055 divided by 12. Final answer will be 11 over 2,400 and equals to MT. N equals to 12 times 6 and the final answer will be 72. Now, let's calculate the final balances that Khadija will receive in account X using S equals to P open bracket 1 plus I close bracket in the power of N. S equals to 38,000 open bracket 1 plus 11 divided by 2,400 close bracket in the power of 72. Final answer is 52,860 ringgit and 95 cents. Calculate the interest received using the I equals S minus P. I equals 52,860 ringgit and 95 cents minus to 38,000 ringgit. The final answer will be 14,860 ringgit and 95 cents. We will calculate account Y. Replace all the information to the formula I K per M. I equals 0.047 divided by 2 and the answer of I is 47 over 2,000. The N where N equal 2 times 6 and the N is 12. Replace the answer to the formula of S equal P open bracket 1 plus I close bracket in the power of N, where S equal 38,000 open bracket 1 plus 47 over 2,000 close bracket in the power of 12, and the final balance is 50,250 ringgit and 50 cents. Khadija should choose account X because high return are offered, which is 52,860 ringgit and 95 cents. With greater interest, 14,860 ringgit and 95 cents compared to account Y, which only offers 50,250 ringgit and 50 cents final balance with 12,250 ringgit and 50 cents interest. The differences of return Khadija received in 6 years between account X and account Y is 2,601 ringgit and 45 cents. 52,860 ringgit and 95 cent minus 2, 50,250 ringgit and 50 cent, and the answer is 2,601 ringgit and 45 cent. Here are some assumptions on advanced withdrawal. It is believed that Khadijah does not make any transaction or withdrawal during the 6-year period. Unchanged interest rate. The annual interest rate for account X 5.5% and account Y 4.7% is constant for the 6-year period.
Part B, question 1. The question is briefly explain the types of annuity. Annuity is a prepayment or deposit made at fixed interval of time where each payment is equal in value. Payments are computed using the compound interest method. Annuity is a contingent annuity which is no fixed ending date and also annuity certain. There are two types of annuity. First, ordinary annuity certain. Second is annuity future value is the total of the annuity at the end of its terms. Its value is obtained by adding the compound amount of the individual credit payment. So the formula term is R for size of each credit payment, I interest rate per interest period, and number of payment during the terms of annuity, and S is the amount of the annuity. So present value is the sum of all the present value of the individual credit payment. Present value must be at the beginning period of an annuity. So A is the present value of annuity. So next, we need to find S, which is the amount of the annuity. We have already identified R, which is the amount Ah Chong deposited RM700. We have also found K, the interest rate, which is 0.0417, because 4.17% per 100 and we got 0.0417. M is 4 because the interest rate compounded quarterly. T is 9 years and 9 months, but we need to per 12 because 9 months, the formula is per 12. So to find I, we need to use the formula I equal K per M. Here, I equal 0.0417 per 4. Next, to find N, we use the formula N equal M multiply T, which means N equal 4 multiply 8, 9 per 12. And the answer for N is 35. To get the final answer, we simply substitute everything we have already calculated into the formula for S. You know that R is 700 and I is 0.0417 divided by 4. This gives us 470 per 40,000. We also know that N is 35 and we minus 1 following the formula. Then we divide by I, which is 470 per 40,000. Finally, we use a calculator and we get the final answer for S is 29,384.29.
Use the formula of A equals to R in bracket 1 minus in bracket 1 plus I close bracket the power of negative n per I close bracket. 50,000 equals to 547.36 cents in bracket 1 minus in bracket 1 plus 19 per 6,000 close bracket the power of negative n per 19 per 6,000 close bracket. Then we need to move the 547.36 to the left. It's become 50,000 per 547.36 cents. The answer for that is 91.34755.919 equals to 1 minus in bracket 1 plus 19 per 6,000 close bracket power of negative n per 19 per 6,000. Move the 19 per 6,000 at the bottom to the left. It's become 91.34755.919 times 19 per 6,000. It's become 0.2892672708. 0.2892672708 minus 1 equals to negative 1 in bracket 1 plus 19 per 6,000 close bracket the power of negative n. So it becomes negative 0.71073272292 equals to negative in bracket 6,019 per 6,000 close bracket the power of negative n. Log negative 0.71073272292 equals to log negative in bracket 6,019 per 6,000 close bracket the power of negative n. On the right side, we need to move the power of negative n. So it becomes negative n times log negative in bracket 6,019 per 6,000 close bracket. Then we need to move the log negative in bracket 6,019 per 6,000 close bracket to the left side. Log negative 0.71073272292
per log negative in bracket 6019 per 6000 close bracket equals to negative n. So for the negative n is negative 108. Then we need to cut the negative. So it becomes n equals to 108. So the answer for the question 3b is I equals to RTM minus 8. I equals to 547.36 cents times 9 times 12 minus 50,000. I is 9,140.88 cents. The answer for question 3c is A equals R in bracket 1 minus in bracket 1 plus I close bracket the power of negative n but I close bracket. A equals to 547.36 cents in bracket 1 minus in bracket 1 plus 19 per 6,000 close bracket the power of negative 7 per 19 per 6,000 close bracket. So for A is 3,783 ringgit and 44 cents.